The COMPRISE Weakly Supervised STT library makes it possible to train speech-to-text models while reducing the need for time-consuming and expensive manual data transcription. The library provides 3 different components that can achieve this. This video shows how to install and run the error-to-UNK component, which can process untranscribed speech data and obtain reliable transcriptions for training speech-to-text models. We begin with the installation of the required tools. This tutorial assumes that you can run shell scripts on your system. If you have a Windows system, then you may want to install Sigbin. If your system does not have Python 3 installed, then we recommend you to install the latest Python 3 version by following the steps listed for your operating system on the website pythonguide.org. Once you have Python 3 installed, you can execute this command to install the required Python packages. The Kaldi Speech Recognition Toolkit and related tools will be installed as part of the setup of the error-to-UNK component in the next step. Now let's set up the error-to-UNK component of the COMPRISE Weakly Supervised STT library. Open the COMPRISE web page. Go to the menu option Software and Survey and click on Software. Scroll down to COMPRISE Weakly Supervised STT and click on Code and Documentation. Click on the Download button and download the source code in the zip format. Unzip the downloaded source code and copy it to the desired location. Change to the directory of the source code and execute the script setup.sh to set up error-to-UNK. Note that this script will also install a specific version of Kaldi, which can take time. If Kaldi is already installed, you can set this flag to false in the setup script. To perform weakly supervised training with error-to-UNK, you should have label data split into training, development, and test sets. Additionally, you will make use of a larger unlabeled training dataset. Each dataset must be specified by means of Kaldi configuration files. In this example, the directory corresponding to the development set consists of 3 files. The wave.scp file contains a list of wave files with a unique ID for each file. The text file contains a manual transcription of the wave files with the same unique IDs as in the wave.scp file. There is no such text file for the unlabeled data because it does not have manual transcriptions. The utterance to speaker file contains the unique ID of the speaker corresponding to each wave file. More files will be automatically created in these directories once the training has started. Now let's go through the steps to use the error-to-UNK component. There are 5 main steps. Let's follow them one by one. The first step is to train the seed acoustic and language models on the labeled training set. If you are new to training acoustic and language models using Kaldi, then there is a sample recipe in the EGS directory. You can skip this step if you have a pre-trained Kaldi chain model. The second step prepares the data for speech-to-text error detection. You must first decode the unlabeled training data and the development data using the seed models. For instance, running this command decodes the unlabeled training data and produces lattice outputs in the specified output directory. Lattice files must then be converted to sausage files using the following command. This creates a subdirectory containing one sausage file corresponding to each lattice file. Note that you have to repeat these steps on the development set. The third step is to train the speech-to-text error detector. This includes aligning the sausages extracted from the development set with the corresponding manual transcriptions, extracting features from these sausages, and training a neural network model for error detection. The outputs of each of the steps are available in the chosen output directories. The fourth step is to obtain more reliable transcripts from the unlabeled training data. It first extracts some features from the unlabeled data sausages and then tags errors in these sausages using the previously trained error detection model. Finally, reliable transcripts are generated. The fifth step is to train new acoustic and language models which make use of the unlabeled training data and the corresponding reliable transcripts we have just obtained. The prepare new data directory script helps you to combine the labeled data and the unlabeled data directories into a new directory. The new data directory can be used to train improved models using the sample recipe introduced in step 1. The steps described in this video are also documented in the README of the COMPRISE Weakly Supervised STT library. Apart from the error to UNK component, you can also explore the components for dialog state-based training and confusion network-based language models. Thank you for watching this video.